Question 1 says, if sulfur 4 oxide and methane are released simultaneously at the opposite ends of an arrow tube, the rate of diffusion RSO2 and RCH4 will be in the ratio A 4:1, B 2:1, C 1:2, and finally D 1:4. So in this question, the keywords are rates of diffusion. So with this, we can tell that we are looking at a question under what? Graham's law of diffusion. And Graham's law of diffusion pretty much states that the rate of diffusion of a gas X is inversely proportional to the square root of its molecular weight. And if we were to have two gases, say gas X and Y, the rate is expressed as Rx divided by Ry equals My divided by Mx. However, in the question we've already been given what? RSO2 and RCH4, so X would be replaced by SO2, and Y on the other hand will be replaced by CH4. So we can then bring this down as RSO2 divided by RCH4 equals MCH4 divided by MSO2. So now we pretty much just have to solve this part of the equation. So we have MCH4 equals the mass, the weight of a compound is pretty much obtained from the individual elements. So we have 1 carbon and 4 hydrogen here, and we've been given a hint over here. So carbon base 12, so 12 plus 4 bracket 1, and that's 12 plus 4 equals 16. For MSO2, it contains 1 sulfur and 2 oxygen, so we have 32 plus 2 bracket 16. So we have 32 plus 32 equals 64. So going back to the equation we have here, so RSO2 divided by RCH4 equals square root of 16 by 64. We have 1 divided by 4, and finally 1 by 2. We can simplify this to be RSO2 ratio RCH4, and we can also simplify this to be 1:2, and this is our final answer. So comparing the options, we can see that option C matches what we got, so that's the correct option. Moving on, we have question 2. So question 2 says, what is the value of X in the nuclear reaction above? So we have 22688 and also X86 radon plus alpha particle. So before proceeding, first off, whenever an element is presented like this, let's look at what it means. So we have A, element A, we have X over here and Y over here. So what X pretty much represents is mass number, and we obtain mass number from what? Protons and neutrons. However, Y represents atomic number, and atomic number pretty much deals with number of protons. So right here it has been represented like this. So what exactly is the alpha particle? The alpha particle is similar to the helium element in the sense that it has 2 protons. That's the alpha particle. It has 2 protons and 2 neutrons. So this means that the mass number of an alpha particle is 2 plus 2, that's 4, and the atomic number is 2. So it means we can represent it like this, 4, 2. Yeah, this makes much sense now. So one thing about balanced chemical equation and all is that the number adds up. So it means what you have in the reactant must be equal to what you have in the product. It means this number here must be equal to this, and also same thing here. 88 must be what? 86 plus 2. So let's take the superscripts. That's 226, equals x plus 4. Upon solving for x, we have 226 minus 4, and finally we are left with 222. So comparing the options here, we can tell that the correct option would be option B. So moving on, we move on to question 3. Question 3 says, the decolorization of the purple color of tetraoxomanganate 7 ion is a test for A. Alkanes, B. Alkanols, C. Alkanals, D. Alkanes. So first things first, what is tetraoxomanganate 7? And also, what do we mean by the decolorization of the purple color? So first off, tetraoxomanganate 7 ion, that's KMN, that'll be potassium. So since it's just the ion, we have MnO4 minus. So one thing you need to know about this is it's a strong oxidizing agent. And in its oxidized form or in its neutral form, it has a purple color. However, in its reduced form, it is what? Colorless. So what this means is whenever MnO4 minus oxidizes a compound, you have MnO4 minus, let's say compound A. It's been reduced, and the compound on the other hand, I'm going to use the square bracket oxygen to represent the oxidation. So whenever MnO4 minus as an oxidizing agent oxidizes a compound, it is what? Reduced. And the color in its reduced state is what? Colorless. So what they meant by the decolorization of the purple color, it much means whenever MnO4 minus oxidizes a compound, it what? Goes to colorless. So what is it a test for? So first of all, we have to find out what exactly can MnO4 minus oxidize among the options. So it would actually oxidize alkane, alkanol, alkanals, except alkanes. So by method of elimination, we know it can be what? Option D. So among these three, it can actually oxidize them. However, it is only a test for one of them. The word test is a what? Key factor. So and the correct option is actually option A, which is alkanes. It can be used to what? Test for alkanes, more specifically the carbon to carbon double bond, and the name of this test is what? The Bayer's test. So again, the correct option is option B. Yeah. So moving on to question 4. The gas obtained as a product of anaerobic action on organic matter buried in the earth is A. Ethane, B. Methane, C. Carbon dioxide, and D. Nitrogen dioxide. Yeah. So keyword anaerobic. What anaerobic pretty much just means is without oxygen. So we are just pretty much looking at the decomposition of what? Organic matter. So organic matter, in the absence of oxygen, whenever it decomposes, it forms biogas. Now, there is no option of biogas among the options here. However, looking at the constituent of biogas is made up of majorly methane and carbon dioxide. So it's about more than 60% of methane and about just 40% of carbon dioxide. So among the options here, it's recommended one goes for methane as the correct option. So moving on, question 5 rather. So question 5 says the basicity of CH3COOH is A 1, B 2, C 3, and finally D 4. So what exactly is basicity? So basicity pretty much represents or refers to the number of replaceable hydrogen ions. Number of replaceable hydrogen atoms, not ions. So in an acid, let's say HCl plus NaOH, we know we are going to get salt and water. What pretty much happens is the replacement of this hydrogen by the sodium metal. So we have, this is pretty much what happens. So rather than HCl, we now have NaCl, and that's actually what happens. We also have H2SO4 plus okay, let's use the same alkali. So NaOH equal, we know we're going to have Na2SO4 . So in this case, you can see that two hydrogens was replaced. Okay, balanced. I think it's balanced now. Yeah, two hydrogen atoms were replaced by two sodium atoms. However, in this case, it's just one. So in this case, you can see the acid HCl has a basicity of 1. However, in H2SO4, it has a basicity of what? 2. Again, it refers to the number of replaceable hydrogen atoms. Now, when it comes to CH3COH, students majority of the time are tempted to just count the number of hydrogen atoms, since in the case of HCl it was 1 and in the case of H2SO4 it was 2. So 4 would be a very wrong option. Let's look at a reaction. So we have CH3COH again with sodium hydroxide. Our product is CH3COONA. So what actually happened was the replacement of the hydrogen atom, by the sodium atom. So and how many hydrogen atoms was replaced? Just one. So that's why sodium is sitting here. And remember, basicity means what? Number of replaceable hydrogen atoms. So it means that the basicity of acetic acid is 1. On a side note, majority of, if not all organic acids have a basicity of what? 1. So the correct option is option A, and that will be our answer.